and in fact, G is the symbol for the metric thing, we'll expect that grad G is grad phi, or G prime is phi prime, which means that if we integrate it out, we'll get G is equal to some constant A plus B phi. Okay? We have now a time metric where the G will be given by A plus B phi. So we have something very weird happening to time. It has some kind of a metric coefficient. Okay? Remember we said we can't really define curvature in a line. We need at least 2 dimensions to define curvature. So we're really going to define this within the context of space-time. So you're going to have something with, let's say, at least r squared, r, the 3 dimensions of space over here. All right, so we're going to expect that there'll be some kind of a space-time metric, meaning distance in space-time between 2 points, and it's measured by something like this, where strangely enough, the gravitational potential of all odd things appears in the time part of the metric, which is very, very counterintuitive. I mean, like, why should the gravitational potential of all things affect our time metric? But we know why. Because we understand that a time warping leads exactly to gravity, and we know that gravity acceleration is a connection, just like the tidal acceleration is a Riemann curvature. And we know that connections can sometimes have metrics that they're built from. And we know that gravity has that kind of structure in it, that it's derived from something. So it makes sense. It's not intuitive immediately, but after you study it a little bit, it becomes intuitive. Okay? So we have 3 levels. Metric. Distance in space-time between 2 points, and it's measured by something like this, but the gravitational potential appears in the time part of the metric. And this is in fact basically the metric that Einstein wrote down first in his theory. He didn't have a covariant theory, he wasn't treating space and time equally. If you were, you would have something here too. You're at a point already where you can begin to understand if somebody says space-time is a 4-dimensional manifold with Riemann curvature and metric, or it's a metric manifold. Okay? And why, when you solve the Einstein equations, it boils down to Newtonian gravity.